Welcome to this lesson. Today we are going through Form 3 Mathematics under Errors and Approximations. And in this topic, the first thing we are supposed to do is to determine the smallest unit of measurement. Then from that smallest unit of measurement, we calculate the absolute error in that particular measurement. And absolute error is usually given by half of the least unit of measurement. That is to say, if a number is given to the rarest whole number, as for example 20, then the least unit of count is going to be 1. That is the least or the smallest unit of measurement. And if, for example, a measurement is recorded correct to one decimal place, for example we have 20.1, then the least unit of measurement is going to be 0.1. If it is given correct to two decimal places, for example we have 20.05, then the smallest unit of measurement is going to be 0.01. Once we have the smallest unit of measurement, we can calculate the absolute error, and the absolute error is usually the least unit of measurement you divide by 2, or you simply multiply that by half. Number 3, you can be asked to calculate what we call the relative error, and relative error is given by the absolute error you divide by the actual measurement. Then lastly, we have the percentage error, and the percentage error is given by the relative error you multiply by 100, since it is a percentage. In this case now, let us go through a question. And the question we have reads, the length and the breadth of a mat are measured to the nearest centimeter and recorded as 28 centimeters and 16 centimeters respectively. Calculate to one decimal place the percentage error in the area. So let us look at the solution to this. The first thing we are supposed to look at, it is the least unit of measurement. And the least unit of measurement, since the two values are given correct to the whole number as 28 and 16, the least unit of measurement is going to be 1. Now to get the absolute error, we have already said that absolute error is half of the least error, that is half of the least unit of measurement, and this one gives us 0.5. For us to understand how we are going to go through this question, let us have, for example, the minimum. We have the actual measurement, then of course we have the maximum here. So we are going to have the maximum for both the length and also the width. So for the length, we have the length being stated as 28, and for us to get the minimum value from the actual, we take this actual, which is 28, we subtract an absolute error of 0.5, and this gives us 27.5. Of course the actual length is 28, and if you want to get the maximum, you take the actual, you add 0.5 to give us 28.5 as the maximum. Then the width has an actual or a value of 16. To get the minimum, we take the actual, we minus the absolute error, which gives us 15.5, and then we take the actual plus the absolute error. This one gives us 16.5 as the maximum width. Having gotten our values, we can now proceed and get what we call the maximum possible area. And to get the maximum area, we are going to take the maximum length, which is 28.5, we multiply by the maximum width of 16.5. And if you take 28.5 multiply by 16.5, you get 470.25 centimeters square. Having gotten the maximum area, we can get the minimum area. And the minimum area is given by the minimum length of 27.5 times the minimum width of 15.5. And if you multiply 27.5 times 15.5, this gives us 426.25 centimeters square. Once we have the maximum and the minimum, we need now to calculate the actual area. And the actual area is given by the actual measurements. That is the actual length of 28. We multiply by the actual width, which is 16. And this one gives us a total of 448 centimeters square. So the first thing we are supposed to get, it is the absolute error before we go down and get the percentage error. So let us get the absolute error. Absolute error in area. And to get the absolute error in area, we are going to get the maximum, or to take the maximum area minus the minimum, we divide by 2. So we take the maximum area of 470.25, we minus the minimum area of 426.25, then we divide everything by 2, and this one is going to give us what value? That is, we have 470.25 minus 426.25, and this gives us 44. So if you take 44, you divide by 2, you get 22. So the absolute error in the area is 22. But what do we need? We need the percentage error. Or simply, percentage error would be equal to the absolute error you divide by the actual, and this is multiplied by 100%, since absolute over actual will give us the relative error, and if you multiply the relative error times 100, you get the percentage error. The absolute error we have is 22. Divide by the actual area, which is 448. Everything multiplied by 100%. And if you work out this question, we are going to have 22. You divide by 448. We multiply by 100%, and this gives us 4.9, correct to one decimal place. 4.9%, correct to one decimal point, and that becomes the answer to this question. Thank you for watching, and welcome to this channel.